Welcome everyone to the Fermentation Association's webinar of A Yeast Primer. I'm Amelia Nielsen-Stoll, editor of TFA. We're a trade group that was launched to support producers who use fermentation to create delicious and often healthful food and beverages. Our goals are to help educate consumers about fermentation and its benefits, support scientific research into those health benefits, and work with food safety authorities to establish clearer and more appropriate regulations in regards to fermentation. Today, we bring you four great speakers: Richard Preiss from Escarpment Laboratories, Doug Checknita from Blind Enthusiasm Brewing and Erosion Wines, Patrick Rue, winemaker and owner, and Matt Hatley, investor and advisor in fermented food and beverage startups. We have many questions already submitted and reviewed with our speakers. If there are additional topics you'd like to see addressed, please enter them in the chat below and we will try to get to them. I will come back at the end to ask some of our audience questions, but for now, I will turn it over to you, Matt.
Great. Good morning, everybody, and welcome from all around the globe. I loved seeing where everybody was dialing in from. I saw everything from Copenhagen to Berlin, and I know that we have people registered in France, Italy, Colombia, Singapore, Iceland, all over the place. So for some of you, I know it's also the middle of the night. So thank you so much for joining. We're going to tackle a subject today that for some of you, if you're into vegetable fermentation, might be sort of clouded in mystery and something that is unwanted. And for others, it's what you live by in beverage fermentation, in wine and beer. And it's the key to unlocking flavors and to making the magic happen. So we're very fortunate to have three guests this morning, very knowledgeable in different areas of beverage making. We have Richard Preiss, who's a co-founder of Escarpment Labs, focused on providing fermentation solutions to craft brewers, and based in Guelph, Ontario, which, as some of you may know, is probably Canada's premier, the home of Canada's premier agricultural and food science university. He holds a BSc in microbiology and an MSc in microbiology and genetics from the University of Guelph, and he's a member of the Master Brewers Association of the Americas and the American Society of Brewing Chemists. So welcome, Richard. Great to have you.
Thanks.
Next, we go north to Edmonton, home to some of Alberta's booming craft beer scene. Doug Checknita is the head brewer at Monolith, the Blind Enthusiasm Brewing Company's facility in Edmonton. Specializes in mixed and spontaneous barrel fermented beers, one of my favorite segments of beer. Doug has worked in the industry for over 10 years. He's attended the first entry of the Olds College Brewmaster and Brewery Operation Program and works and consults for various breweries in Canada and in Belgium. So welcome, Doug. Great to have you.
Thanks for having me.
And then we go to Napa Valley, a region which needs no introduction to wine lovers on the call. Patrick Rue is a winemaker in training and owner of Erosion. His career in beer started at the Bruery, B-R-U-E-R-Y, which he founded in 2008. In my opinion, one of America's best brewers of Belgian-style beer and probably one of the most innovative brewers in the nation. So it's great to have you. He's developed hundreds of different beers and experimented with many ingredients, techniques, microorganisms to create unique and delicious flavor profiles. Along the way, he became a master cicerone in 2014. Patrick, co-founder, spouse Rachel, and daughter Charlotte moved to Napa Valley in 2018 to found Erosion, an adventurous producer of fermented beverages. The lineup currently consists of eclectic Napa Valley wines packaged in cans and will soon include beer and mead. Fantastic. Great to have you here, Patrick. Thank you.
Thank you, Matt,
for joining. So I'm going to hand it over to Richard, who's going to give us an introduction and some insights into Escarpment Labs, and then I'm going to ask Doug and Patrick to chime in. And then we have a lot of really great questions submitted by you guys that we'll tackle after that, and then we'll go to the ones in the chat. So Richard, over to you.
Thank you so much. I'm just going to present a few slides and just try to ground us here, but I'm not going to take up too much time because I know there's a lot of really good questions coming in from the audience. Let's go ahead without further ado. as mentioned, we're a yeast company. So coming at this from a little bit of a different angle than the brewer and the winemaker that we also have here. We make yeast. That is our bread and butter. We develop and sell yeasts mostly to breweries. We do some work with some cider makers and distillers and, maybe wineries in the future as well. So, we try to keep an open mind with this. We've been following along with a lot of the Fermentation Association webinars. We're trying to learn everything we can about things like koji and miso and lacto ferments. So that's been really awesome. This has been a fantastic resource. So I just wanted to, make sure that appreciation from the beer side is known. One of the important things to talk about with the yeast that we use in fermentation is that they are domesticated, just like how we've domesticated dogs and cats. And it's kind of a funny story because you don't really think about it this way, right? You can go and look at a toy poodle and know like this thing is not going to survive in nature. But with yeast, it's a microscopic organism. It's kind of harder to know that, but the yeast that we use in brewing or in sometimes in winemaking or other ferments are also the product of domestication. They're the product of humans, whether they intend to or not, repeatedly working with these yeasts in fermentation environments, and those yeasts adapting to whatever the heck the humans are trying to do. So if someone's making beer for over the span of hundreds or thousands of years, then the yeast is going to change to kind of get better at that, right? It's going to get better at fermenting that beer, and maybe it's not going to be so good at surviving out in the wild, just like our toy poodle versus our wolf. And luckily, some really smart scientists have actually dug into this. So, it's not just this abstract concept. People have gone through and done genome sequencing of thousands of yeasts. And I'm not going to get into the details, but I think the key point here is that even if we go and look at the genetics of the yeast, the history of the yeast and how it's evolved, we see these pretty clear patterns where yeast that is used in beer is genetically beer yeast. It has, a very, very specific set of traits that make it good at fermenting beer. The same is true for sake. The same is true for wine. The same is true for wild yeast. Wild yeast will also be better at surviving in the wild than it is maybe in a beer ferment, and so on. So, this is really interesting because it tells us that the genetic history of the yeast kind of maps to what we actually do with it. And it's an important point. It's really hard to make a wine yeast do the job that a beer yeast does, but sometimes there are some opportunities to experiment. And I just wanted to touch briefly on the current state of yeast, but I'm hoping that Doug and Patrick will be able to talk about some, applications of what they're doing. I wanted to share this, these awesome drawings from some friends down at Live Oak Brewing in Austin, Texas. I just love I just love this little wild yeast character. Maybe someone should get a tattoo of that someday, but good example. Yeah, there's wild yeast, there's domesticated yeast. Different people use these things for different purposes, especially in the wine world. We see the use of, wild or, non-selected yeast pretty commonly. And that can confer specific traits. It might contribute to things like terroir or, regional differences between wines. But we also see pure cultures used in a lot of different types of fermentation, whether it's wine or bread or beer, sake. And then we also see this whole other world of mixed cultures. Like what happens if the yeast is mixed with lactic acid bacteria to make, for example, a sour beer, and you get all sorts of opportunities that way. So there's lots of different options when we just talk about yeast, right? There's lots of different yeasts out there. And I'm just going to touch briefly on beer yeast because that is where I specialize. Our history has been working with beer yeast, although, like I said, we're trying to keep an open mind. Beer yeast is kind of funny because there's a lot of different types of yeast that are kind of tied to the style of beer that the brewers are making. Like you can't really make a American ale without those super clean American ale yeasts. Likewise, you can't really make a saison without a really expressive fruity yeast. So there's a long-standing history of brewers kind of matching the style of beer they're brewing very specifically to the type of yeast that they're going to ferment it with, because the yeast has such a huge impact on the flavor of the beer. And you can get a lot of these yeasts from a lot of different yeast companies. And there have been some really, really interesting opportunities or ideas that have emerged in the beer side in the last few years that we're excited about. So whether that's people rediscovering traditional yeasts. So if you've ever seen a brewery talk about Kveik, that's a whole rabbit hole that you can go down of traditional yeasts that have been rediscovered. Yeast companies can make hybrids. They can crossbreed yeast just like you can crossbreed tomatoes or peppers and make something new. And then there's also, and especially in the US, there's a more recent trend of yeast genetic engineering. So specific genetic modifications to improve or enhance certain traits of the yeast. And, I know that that's more of a controversial subject, but it's fascinating, and it seems to be picking up steam on the beer side. In general, I think in beer, we've been pretty slow to respond to new ideas. I think the companies that develop wine yeasts tend to do things faster and do a little bit more science, but we're catching up and we're still learning. And that's the exciting part of what we're doing is, no one really knows the best approaches to using beer yeast yet, but there's a lot more new science that's happening, and a lot more brewers that are experimenting, and together we're collaborating to understand how to work with yeast better and kind of unlock new flavors and new possibilities. So again, I showed that huge family tree. There's also been some work on beer yeasts. Again, not going to go into the specifics here, but just to highlight that there's a few different subfamilies of beer yeast. So beer yeast is not beer yeast. What's really cool is that as yeast has been used in a lot of different parts of the world for making beer, they've become even more specialized. So British yeast is British yeast, and they have certain traits. Likewise for the yeasts that came over to the US and started getting used in breweries, and likewise for some of the yeasts that stayed in Belgium and Germany. So that's pretty cool. That's pretty interesting to us, is that you really see this specialization and domestication of the yeast to kind of meet the fermentations that the humans are trying to do. And a lot of this started, probably thousands of years ago, and it's really hard to trace it back, but it's pretty clear that we've been working with and domesticating yeast for a very long time. And this is important because we have all of this genetic diversity and all of this specialization, and ultimately that leads us to flavor diversity. And I think that's what a lot of us are, looking to our yeast for, is new opportunities to create or modify flavors in the fermented products in a way that creates something that's greater than the sum of its parts, right? You're taking, in the case of beer, you're taking this kind of gross, bitter soup of sweet barley and hops, and yeast makes it taste good, and that's really important. And depending on the yeast that gets put in, it can make it taste like 400 different things. So there's so much potential there, and I think that's really exciting. And just to show some of the work that we've been doing here, for example, is trying to map out, what kind of different things can the yeasts that we work with as a beer yeast lab do, and understand, what yeast might be good at what applications. And there's lots of different approaches to that, but yeah, just to sort of show a quick example of the kind of stuff that we're working on, where, a lot of brewers are looking for these traits, these, unlocking flavor from the hops, getting some fruity aromas, because a lot of consumers want these high flavor beers, and recognizing that there aren't a lot of yeasts that are extremely good at both of these things yet. So maybe there's an opportunity for some of these developments, like yeast crossbreeding or genetic engineering, to improve those traits and give brewers some of the flavor intensity that they're looking for. So that's it for me. Hopefully that's a helpful overview of at least where we're at in the beer world, but I'm really excited to hear what Patrick and Doug have to say as well. And I think I'm going to be handing this one over to Doug, who I know we've been working with a little bit on, at least on the pure culture side of things, but has a lot of awesome experience with spontaneous fermentation as well.
Yeah, Doug, maybe you could talk a little bit about some of the things that you're doing in terms of spontaneous and barrel fermentation. When and why you choose to do that versus when you use cultivated yeasts and so on. Maybe drill down a little bit in there.
Yeah, I think Richard had the perfect segue with a lot of what he talked about in his presentation there. At Blind Enthusiasm Brewing, where we have everything that we're doing is fermented as mixed cultures. So whether it's spontaneous or mixed ferment, and the difference being one being a natural source of the organisms and the other being cultivated, where everything's taken the path of like in using Richard's presentation as referenced in a chart of like history and lineation and stuff like that, we're more closer to the top of that, like closest to like new yeast formations and new family trees and things like that, especially with the spontaneous fermentation. So we're taking the base of beer, which is wort, and we're trying to make a wort that'll push and change those yeasts to do what we want and get that clean flavor that'll make a beer that tastes good to the human palate, or to what we define as beer nowadays. The added complexity to that is there's also lactic acid bacteria and other organisms there in there as well. With the mixed ferment, we're essentially taking that same process that we do for the spontaneous, but we're going down that family tree almost to the very bottom, where we're working with labs like Richard's, where we're taking pure cultures and trying to replicate the use of these organisms that in that mixed culture environment, to kind of have more control than you would with spontaneous, so you can create things that you wouldn't be able to in the spontaneous world. So that's, the process is almost identical except for that inoculation and that hierarchy of the yeast.
Yeah. And Patrick, anything to add? Maybe, you know, the brewery was one of the most innovative, or is one of the most innovative breweries in North America, and known for experimentation. Maybe if you could talk a little bit about that. Maybe talk about some of the things too that were surprising along that journey, discoveries, maybe things that didn't work as well.
Sure. Yeah, just in beer making, yeast has always been a central part of, you know, kind of manipulating the flavors or getting the flavors you're trying to achieve. I know, you know, at the brewery, we did a lot of, you know, keeping our yeast on slants, and used some yeast that we just discovered over time from home brewers who, you know, let us, you know, who loaned us their yeast, which became kind of our primary yeast strain, to, you know, doing native ferments, and then selecting the yeast that, or trying to select the yeast that that we liked while eliminating bacteria and, you know, other yeasts. So yeah, I think yeast is such an important thing with beer, which when I got into wine, it was interesting how yeast is more about functionality than about kind of flavor development. You know, with wine, you're using, you know, the grapes where they're grown, the varietal, the decisions that you make in the growing process is how that flavor is, you know, a big part of how that flavor is achieved. And yeast is about, you know, the functionality. So the alcohol tolerance, the nutrition needs, you know, the temperature requirements. So, you know, hotter yeast is going to be, or yeast that can deal with hotter temperatures or likes hotter temperatures, is going to be great for red wine fermentations to extract tannins, where cooler wines that prefer a cooler environment are great for, you know, preserving that kind of fruit character of white wines. You know, yeast, you know, you want to avoid hydrogen sulfide production, but sometimes that's at the expense of other things. You know, yeast that have a protective factor, you know, killer yeasts will kind of prevent the growth of other yeasts or outcompete them. And, you know, also how long a wine takes to ferment has an impact on the flavor, especially red wines, with allowing it to sit on skins and that kind of thing. So yeah, it's interesting. So we're getting into yeast on the wine side on how it can contribute flavor, especially for younger white wines white wines that you're not oak aging. You know, I think the yeast can play a huge role, as well as, you know, younger red wines that you might want to do in kind of that Beaujolais style, where the yeast is, you know, produces so much of the fruity character to it. So it's been interesting, kind of the differences between the two worlds.
And Doug and Patrick, maybe tell us a little bit about how you achieve some degree of consistency when you're doing wild and spontaneous fermentation or barrel fermentation.
Yeah. Well, in my experience, there is very little consistency. It's about having a lot of different lots to blend with. And most, sometimes you'll find that perfect, fermentation where it kind of captures everything that you wanted, some of that funk, the right amount of acidity. But oftentimes you'll have batches that are super funky, not very acidic, others that are kind of not very complex, but super acidic. So, blend those two together and you might get the balance that you're looking for. But I'm sure I'd like to hear Doug's perspective. Maybe there's a better way.
Yeah, no, I think in some ways I agree with you a whole lot, especially in the mixed ferment world. When it comes to spontaneous and getting consistency, blending is definitely part of it. And a big part, especially when you're targeting like those fine details of flavor in a finished product. For spontaneous fermentation, especially in the early phases, there's kind of two main factors that we look for to try and hit a range of consistency in terms of like predictable acidity times and things like that. And those are what your base wort is. So what you're feeding the yeast and bacteria and all the other mixed cultures. If you can make that consistently, but also set it up in a way where you have like IBU controls so that it stops certain organisms from growing, but also complexity of carbohydrates. So you are intentionally staging those, which organisms are coming through. So using like a more complex wort that has everything from simple glucose all the way up to soluble starches and high nutrient loads, so that over the long period of these fermentations in barrels, it's actually still fermenting. Even on micro levels, it's not just fermenting done and then aging after that. So, and then the other big one is developing cultures within your brewery. So using barrels become more consistent over time if you're washing them the same way, and you get some of the cultures that you've been selecting for over time continuing to mutate and go down those different generations, and you'll see more stability. There's breweries in Belgium that have been working in the same facility, and you can taste stuff year to year, and it's almost like you'd say that's the same beer with minute differences here or there, and then you get that consistency through some blending. So very similar, but with spontaneous, there's definitely ways to push it. And then with mixed ferment, consistent pitching rates, and then using the same barrels over and over and things like that, you can start to get some of that same thing. But because some of those organisms aren't as hardy as, say, the more younger generationally ones, you actually can get like die off randomly and things like that, and get some of what Patrick's saying of like, man, we did the exact same thing, but for some reason now this is like way more acidic, or this is way more something. So it's kind of counterintuitive that the more natural process is a little bit easier to like drive slowly than some of the mixed ferment stuff where you're pitching pure cultures. So yeah.
Yeah, great. You also answered one of the audience questions. We're going to sort of dive into some of the conditions that create particular aromas and flavors in yeast. Richard, anything to add to that? So aside from the type of yeast, obviously, what are sort of the conditions or the background that make up the flavors?
Yeah, like beyond the type of the yeast, there's a lot of things that we can choose to do that impact how it behaves. So like temperature is the big one. Usually yeast is more expressive at higher temperatures. So like if you want a more neutral fermentation flavor, then usually a colder, regardless of what you're fermenting, usually a colder ferment is better. And then if you want some crazier flavors from the yeast, then typically higher temperature is better in that case. There's other things you can play around with, like the amount of yeast that's added as well. If it has to work harder to grow and make more cells, then usually you get a little bit more flavor expression as well. So that's also why, throwing too much yeast at a ferment, whether it's beer or even bread, right? Like think of like, bread recipes where you're putting in a tablespoon of yeast. You're not actually getting a whole lot of like natural fermentation flavor. You might just literally taste all the yeast that you added. So I think it's relevant, like no matter what you're fermenting.
There's a couple of questions here from people looking at brewing as a hobby. Are there yeasts that are easier to work with? Ones that you'd recommend, hey, if you're starting out in home brewing, try these because they're a little bit more forgiving.
I think.
Sorry.
Oh, sorry.
Go ahead, Patrick.
Sorry, Richard. You probably have the better answer for this, but I found as a home brewer, kind of Belgian-derived yeast strains were the most forgiving. They could deal with lower pitch rates. You might not have your hydrometer or know what your gravity is, so can tolerate a higher, both high and low levels or gravity levels. Temperature, if you're probably not going to have temperature control, so being able to deal with a hot environment, Belgian yeasts are great. But probably Richard has some really great specific ones.
No, I think that's a good answer because if you go to a lot of the breweries in Belgium, the temperature control is not necessarily existent as well. So it's not that far removed. The other thing I would add is, and I talked about it previously, is some of these traditional Norwegian yeasts or Kvike that have kind of taken the beer world by storm, and especially on the homebrew side, they have some advantages in the sense that you can ferment at a pretty wide range of temperatures, and they're super forgiving. You get usually you might get different results, but you usually get good results. So I think those have a lot of potential value on the homebrew side, especially as they become more popular and there's more like homebrew recipes that make use of it and kind of make it a little bit more accessible. And you can get these things from pretty much every yeast company now.
Yeah. And there's another question from somebody just asking about cultivating yeast themselves and the yeast at home, and what's sort of like the minimum lab setup. Is that even possible? What would that look like?
Well, you don't necessarily, I mean, if you just want a yeast culture to ferment with, you don't need a lab at all. I mean, it can be something as simple as like a sourdough starter. But beyond that, like if you want to get into the world of pure yeast, that's usually where you need at least some of the basic microbiology tools. So that's things like agar plates and, using that as a tool to basically filter out the yeast or the sample to get down to like a single colony of yeast so that you can purify it. And then if you're able to, basically put that sample onto the agar plate and get a yeast colony that's pure off of that, then there you go. You already have your own, purified yeast. And that is very much possible at home. I know that there are some like kits out there that people can buy to make their own agar plates and experiment with this stuff at home. And it's totally possible. I mean, you can find wild yeast everywhere. Like you can find it, fruits and tree bark are both awesome places to look for wild yeast. And there's definitely lots of stories of people who have had success, isolating yeast from the wild and using it in their ferments.
Wow. Okay. And as a, sorry, Doug, did you want to add something?
Sorry, with that, the one thing with doing things from nature is there is a safety factor in it, especially with like high pH, which is generally where homebrew beers end up. Something that you have to be wary of doing any of this stuff is you can get stuff that's harmful to human health. So you have to be careful with your pHs and what controls. So there is an amount of like you can let it go, but within a safe region. So things like pH strips and some of these other things can help make sure you're within safe pH ranges for things, and leaving stuff for certain amounts of time so that stuff can die off and things like that. There can be low risk danger of doing things by just like the natural way. So just something to note there with that.
Yep. And my background's more in lacto and sourdough and so on, where you kind of, the yeast that you get are kind of the yeast that you get. And there was just a study done about sourdough, about variation in places, maybe not being as big as people thought they were, right? If you're a home brewer and working with wild fermentation, can you influence that to some degree, or just the wild yeast is the wild yeast that you get?
like I said before, with like what we do even on a large scale, is what you're fermenting in has what you create to ferment in has a lot to do with what will actually ferment it. So you can pH adjust your wort down to, one of the comments just said like 4.5 or below, and that'll generally stop anything really bad from getting you there. But also doing more complex worts, so things have time to go through. The more aggressive stuff will get through the simple sugars, and then more hardy yeast strains like Brettanomyces can come in later and get some of those other ones that aren't quite as aggressive in nature and things like that. So what you're fermenting has a lot to do with it. I'm sure Patrick can talk on this a bunch, but in the wine world, it's really simple sugars, generally speaking, and they've been fermenting the natural way for millennia. So
Yes. Sorry.
Yeah,
I've been doing it for
segue.
2 years, so you know.
Well, it's a great segue because this is one of the questions that came in as a brewer turned winemaker. So how is that your experience as a brewer influence how you look at yeasts in sort of winemaking, and how do you approach yeast selection? You talked about it as being much more functional, but of being, having some degree of influence over especially white wines. Maybe tell us a little bit more about that.
Sure. Yeah, I would say when picking a wine yeast, this might be more marketing speak, but it's all about preserving the integral fruit character of the varietal, and being true to the varietal, those kind of things, which is great because you're spending, especially here in Napa, you're spending a lot of money on certain types of grapes to be grown in a certain area, and why would you look beyond that? But we are working with a great company called Berkeley Yeast that does genetically engineered yeast. So let's say, for Napa Valley fruit, maybe it's a really fun use, but maybe not the most practical use. But say for a Chardonnay, we take the same juice and we ferment it with about 4 or 5 different yeast strains and kind of get the impact of the yeast for each of those. So one of the strains, my favorite, I forget the real name of it. I think it might be Wildflower. So known as 480.
I think Patrick just froze.
Transforming your Chardonnay, I froze. Can you see me?
Yep, you're back.
Sorry about that. So yeah, you're transforming a Chardonnay, which is often a little bit neutral in character, to something more like a New Zealand Sauvignon Blanc, which is really expressive and tropical fruits and grassiness, and with the weight of a Chardonnay, which is pretty appealing. So yeah, traditionally the wine world's not looking at the impact of flavor, but I think there's a lot of opportunity there.
I mean, do you think that'll change? Do you see people experimenting that, or anyone of note that's doing some interesting things there that come to mind?
Sure there is. I think doing the natural fermentations, I think, are probably the most interesting thing, or kind of the differentiation with some wineries, in that their vineyards are propagating a really distinctive yeast trait, which kind of goes into that concept of terroir. So using yeast as a part of that kind of sense of place, which is really fun. And it's amazing how wine is, I feel like God intended wine to be made, because it's just, you let nature happen, and you'll probably have a pretty good result with natural fermentation. Where in beer, it's very touch and go. You have to have the perfect conditions, and being able to do spontaneous fermentation. But those yeasts that choose to live on the skin of grapes are in ample enough quantities to produce some pretty great wines. And it's interesting, the off flavors that you might get initially in one of those fermentations that are just cleaned up with time. It could smell very much like nail polish remover in the first week or so of fermentation, and then just kind of it really evolves. It's crazy. It's very scary as a brewer to deal with that. So I don't do very much of it.
Well, I can see the questions are coming in fast and furious over the chat. Amelia, why don't we turn it over to you to look at some of these questions? I've just seen some great ones kind of rolling by here as we've been talking about some of the ones that were submitted.
Okay, thank you. Thank you so much, guys. This has been so informative. Can you first please tell us about the interaction between lactic acid that live on the surface of grains and grapes and those introduced from a commercial source? This question says, sometimes the relationship can be symbiotic, other times it's a battle. Anyone want to take that one?
I think I had a little jitter. Did you guys hear the question okay?
I kind of got the gist of that.
I'm
Maybe-
sorry. Let me try it again. Did my internet connection?
It was
Waiver.
dropping in and out. Yeah, so I think repeat the question so that we can make sure that we get
Okay.
it.
Oh,
I'm sorry. Okay, this is a question from one of our audience members. They asked, can you please talk about, am I okay? Can you hear me now? Okay, they said, can you please talk about handling the interaction between the yeast and the lactic acid bacteria, the grains, and those used from sometimes it's really symbiotic, other times it's a battle. Anyone want to take that one?
so just to clarify, it was how do you handle the interaction between natural yeast and bacteria or lactic acid bacteria in fermentation? Sometimes it can be symbiotic and sometimes it can be natural. Is that kind of what everybody got?
Yes, or a battle. You know
Perfect.
what? I will. Someone suggested I put it in the chat because it was a long one. And I'll paste it in here too. If that helps.
Perfect. Do you mind if I start since I'm talking?
Please.
I kind of touched on it earlier with like comparing the spontaneous to the mixed ferment. It's one of those things of like organisms in natural environment tend to want to like will do what they're gonna do, and as soon as you kind of isolate them and then put them into pure cultures, it's kind of like a Pandora's box of as soon as you touch and start manipulating, they're not going to do what they do in nature. So in the spontaneous beer, I see that it's a little bit more symbiotic and you have to control it through exterior controls. Whereas with the mixed ferment stuff, they often, once they're in pure culture and you're putting them back together, they more often than not want to battle each other, and you have to fine tune it a lot more and figure out which environments are a little more symbiotic than the others. Richard can probably speak on his experiences of working with clients.
No, I would agree. Like, I think at least in like these specific contexts of like spontaneous beer or spontaneous wine, it's really more likely for those microbes to already have existed in harmony. So they're probably more likely to continue to do so. Whereas if we do try to add an intentional or a commercial culture, and especially when we get into mixed cultures, like blending yeast and bacteria or multiple yeasts, oftentimes because you're kind of like fabricating a community, it often is not very stable and it'll change. Like it's something we see if we do make like a mixed culture of yeast and bacteria and then try to use that batch to batch, whether it's like a sourdough or whether it's a beer. Oftentimes that community changes and eventually settles into something that's stable, but usually whatever we come up with in the lab isn't necessarily what nature wants. And usually life finds its own path and eventually it settles on something good. And like, that's kind of one of the fundamental problems we're trying to work on is like, how do we actually make this reproducible? Because I know people want, especially in sour beer and things like that, people want these mixed cultures, but how do we create something that's closer to what might show up in a spontaneous ferment, for example? And that's a big challenge.
Thank you for that. Okay, we had a question coming in about good stress versus bad stress for yeast, especially in winemaking. Is there a way to encourage one over the other?
I think, proper nutrition is a big part of it. Yeast, the same quantity of yeast in a poor nutrient environment is going to be producing a lot of fusel alcohols, which are, not tasty, and is going to have a harder time cleaning up things like diacetyl. It will produce more hydrogen sulfides, more of that stinky sort of sulfur odor. Where I think if you take the same quantity of yeast and you give them a good environment where they can really flourish, they're able to propagate to a quantity that they can actually ferment whatever they're fermenting, all the while producing some of the crazier esters that happen during stress. I think temperature also a big thing is, if it's not hot enough for those yeast to really be activated, they're not going to produce very good character.
Okay, we had a few questions about experimenting with wine yeast in beer. Have any of you experimented with that? Is it possible for a wine yeast to survive in beer?
I can take that. Or
yes,
go ahead.
Please, Richard.
It's possible, but they're kind of like specialized for different purposes. The special thing about beer yeast is that they've learned how to ferment all of these complex carbohydrates that show up in beer, like Doug talked about. And wine yeast has not figured that out. So typically, if you throw a wine yeast at a beer, it ends up finishing pretty sweet because not all the sugars can get fermented out. And they have other nutrient requirements too. So sometimes if you throw a wine yeast at a beer, it can be like really sulfury as well. I'm not saying don't do it, but what I'm saying is it can be a challenge. I have seen some good results, especially if, one of the benefits of the wine yeast is that they leave some sugars behind. So in some of these sort of mixed culture scenarios where maybe you have another yeast or bacteria in the mix, it can actually be beneficial because you're leaving something behind for the other microbes.
Patrick, did you have anything else you wanted to add?
I think Richard did a great job. I guess if the carbohydrate profile is very simple in the beer, there's maybe if you're using a high level of dextrose or something like that, the wine yeast might perform better. But yeah, generally it's, I haven't found really great results from it. And the inverse goes as well. We use some beer yeast with wine, and it has a hard time coming. It doesn't attenuate all the way, just because having all fructose to ferment's not a very pleasant place for beer yeast, I guess.
They struggle with fructose. They're not fans.
A question for all of you. Can you share with us a story about dealing with a contamination issue? What were the symptoms? What steps did you use to remedy the problem? Anyone want to start on that one?
So I got the question as contamination, what to do when it happens. Yeah, we at the brewery, we had an issue with contamination when we were producing both mixed fermentation beers with inoculated,
yes.
or pure yeast where we did not want sourness. And that was a huge it can work on a very low production where you're able to completely sanitize between, but in a higher production environment, the yeasts are actually getting in the air, and it's impossible to keep it keep it clean. So, you know, there's one thing about, you know, being able to clean stainless and replace gaskets, which is certainly recommended. But when it comes with packaging, there is going to be some element of exposure to the air in packaging. So just doing things not in the same place is my recommendation. But yeah.
Yeah, the going off of doing stuff in two different places, that's why Blind Enthusiasm has two different facilities. So we have a small brew pub where we're doing our like more clean ferment beers that use pure cultures, and then the Monolith, which is what I run, is only mixed ferment and spontaneous. And even then, with the spontaneous and mixed ferment, we keep them on different floors, and we strip down tanks when we're blending between the two to try and mitigate cross contamination there. There is other things in and I'm sure Richard can talk better on this, but even within yeast strains, there's yeast that'll contaminate. Like diastaticus is a huge problem within the brewing industry now, where there's genes that are present in certain yeast that will Richard will probably want to take this one, but they'll help stick around, but they'll also metabolize things that other yeast won't, which helps them stick around. So, Richard.
Yeah, I think there was a piece in the start of the question about like how do you know when you have a contamination? I think that's important as well, and it's kind of tricky. But you know, the advice that I always give to people, and you know, this is even in some of our SOPs for yeast production, is you know, use your senses, smell, taste, because that'll often tell you if something's going wrong. If it doesn't smell right and doesn't look right or doesn't taste right, then chances are, you know, from a microbial perspective, it's not right. Either the microbe you have in there that you've added is not happy, or there's something else that's contaminated it. So, you know, we have contaminations, you know, I'll be very transparent about that. We're in any given week growing 30 to 50 different products. And that means that there's a lot of just by pure numbers, there's a lot of opportunity. And oftentimes a lot of these problems are first diagnosed by someone saying, okay, this yeast doesn't smell the way that it's supposed to, right? It shouldn't smell like rotten eggs. What's going on? So, you know, we're always doing the microbiology and we catch that stuff, but we often have advanced warning just from using our senses. And I think that's really valuable because there's always that possibility, right? These microbes are all around us, just like how you can make a sourdough starter out of basically thin air because eventually enough yeast gets in there to take off. You know, we're always battling with wild microbes when we're in this, you know, propagating microbes business.
I just have a follow-up question for Doug and Patrick. So aside from contamination, can you think of an instance where, you know, in all of the experiments that you guys have done and all the new flavors that you guys have tried, where you try to mix fermentation or a different kind of yeast with a different set of, you know, ingredients or flavor profiles, it just didn't work? Like you would say, guys, don't ever try this.
Well, I mean, having tried a lot of different things, the spontaneous world is not very well documented. Like a lot of what I had to learn was literally going to Belgium and working for the breweries that are doing this all the time. And then you take it to a different region, and you're gonna have to fine tune your process a touch to like get the flavors that you're looking for and the cleanness of fermentation and stuff like that. So I've made quite a few batches of spontaneous where it's been like, this just tastes like fatty acid. And there's no saving it. There's nothing you can do. And it's just like Richard said, we didn't even have to go to the lab. We just used our senses and we're like, yep, this is unusable. But then we fine tune some stuff and some of those controls and you can come back from it a bit. But there's also times when we've used done tests, not at Blind Enthusiasm, but other breweries I've worked at where we're doing fruit beers and we've tried a fruit and the natural organisms on the fruit started re-fermenting the beer, and man, it was a very different beer after 2 weeks being on fruit than it was before. So there's I could probably go on for hours on like the crazy stuff that can get into beer, because it's not a very stable product to begin with. So
yeah, the only thing that comes to mind is using pineapple in beers, like kills the yeast. Or we made this kind of Christmas seasonal 5 golden rings using pineapple, and the enzyme in the pineapple kills the yeast. Or we were getting like 0% yeast viability at the end, fully attenuated, but like the yeast was completely dead. So anyway, I know the question was about what things not to mix, but I thought that was interesting.
Okay, I'm sorry, guys. Can you hear me better? I'm on phone audio now. Okay, thank you. Sorry about that. Okay, we had a question. How many generations of yeast do you use before repropagating it for brewing or winemaking?
Well, with winemaking, you only got one shot usually, because the grapes come in a certain time of the year. And with the alcohol content, you don't want to rely on reusing a yeast strain. It's usually just more dependable to pitch new cultures with each load of grapes that comes in. And with white wine you could collect the yeast, but with red wine, you have the must, and you have the skins. There's no real way of collecting unless it's just very difficult to get the right to be able to. I guess you could grab like a pile of grapes and throw it in the next one, but wouldn't. That's scary. But on beer, I think it depends on the yeast strain and how certain yeast strains are going to mutate more quickly than others, and especially when they have more dominant yeast characteristics. You'll notice you'll notice those things. I know a lot of lager breweries, I don't see a lot of genetic drift, so they constantly use the same yeast. Or the Ringwood yeast strain, I think Shipyard, I think, reports to being using the same, never repropagating their yeast and just continually reusing. But certain, so I've found anywhere from 3 generations to an unlimited amount of generations. But I think 8, I feel like, is pushing it as kind of where you want to be if you don't have any contamination. You get a good economic use out of your yeast without taking too much risk.
With that as well, you talked a lot about the genetic drift side of it, but in a brewery especially, it has a ton to do with how you're handling it too. Some breweries can push a yeast strain a little further because they're doing everything right in terms of making sure they got viable cells when they're cropping, how they're cropping, nutrients and slurry solutions and stuff like that, oxygen revitalization in between repitches. But then if you're like a small brew pub and you don't have the resources or the ability to do that, you might only get like a few pitches, or should be only using a few pitches, because you can't handle the yeast properly as well.
Thank you. Doug, we also had a question specifically for you. We had a few questions about the flavor. Describe the process of aging your hops and why they go from being more of a cheesy, rancid aroma to eventually smelling great again.
So, little off topic, this being a yeast conversation, so I'll do this really high level. With hops, just like any vegetation that has high resin or oil and acid content, you're going to get both oxidative breakdown and enzymatic breakdown, and different compounds are produced and stored within the cell walls of the plant. So on a simple term, is those compounds that are produced that smell like cheese are fatty acids essentially, or oxidized fats in some cases. And the reason they go from bad to good is enzymatically they're broken down, or oxidatively they're broken down. Some really simple stuff to compare it to would be about how they treat tea for getting the different darknesses of different tea varieties and stuff like that. It's not like super well known in this context, but if you extrapolate from data from the hop growers on like hops going bad, they treat it as like a bad thing. I treat it as like a good thing for aged hops, but you can look at some and do some cross comparisons. But yeah, we'll keep it on the subject of yeast. We could do a presentation just on that.
Thank you, Doug. Okay, Richard, for you, we had a question. As more strains of yeast are developed, how precise has the industry gotten with, I guess, drilling down to those associated flavors that yeast will produce? This question says, in other words, are we precise at predicting the flavor yeast will produce, or rather predicting certain levels of compounds that are associated with that flavor?
We're getting better, but it's still not perfect. There's still, a good dash of mystery, a good dash of scientific mystery. So for certain traits of the yeast, it actually is very predictable. And we've seen yeast companies and academic labs be able to prove, that it's very possible to totally tweak these things. So the classic example in beer is what's called phenolic off flavor. So some yeast, the Belgian yeast have this active enzyme, and it gives them that spicy clove aroma that's desirable there, but undesirable in a lot of other beers. And that's a result, the loss of that trait in a lot of the yeasts that are out there, a lot of the ale yeasts and lager yeasts that are out there is the result of just one single base change in that gene that inactivates it. So like in that case, it's relatively simple for a yeast company to either breed in that trait or genetically modify for that trait and create a yeast that's that is no longer has that phenolic off flavor, and that can help reveal some really interesting underlying characteristics when that's out of the way. So I know that there's a couple companies in the States that have experimented with that. But like on the other hand, there's some of the most desirable traits of the yeast that we work with are still very poorly understood. It's still sort of understood how yeast is able to unlock flavors from hops. And since hoppy beers are the most popular, this is really economically important. So there's still like a lot of mystery there. We know a little bit about the genetics, but when you go in and tweak things, it doesn't quite line up. And likewise, a lot of the fruity aroma compounds that yeast makes, like yeast can make esters, aroma compounds that smell like pineapple. So we're talking about pineapple again. You can get that from your yeast, but that is also very poorly understood. You can't go in and tweak one gene and suddenly get 20 times more pineapple aroma. It doesn't seem to work that way. So there's still a lot of kind of basic science that we need to do to understand, like, under the hood, how does the yeast work before it's going to be possible to either tweak or predict flavor outcomes better. But we're definitely working on it. A lot of other people are definitely working on it. So I think that there's going to be a lot of exciting things happening in the next few years.
Oh, that's so fascinating. Okay, Patrick, I know you addressed this a little bit earlier, but traditional winemaking, it's always the yeast has been used off the grape skins or the natural flora of the environment. Do you see new winemakers? Are they continuing to use this tradition of using the wild yeast, or are they more exploring new yeast strains for fermentation?
Yeah, I feel like maybe 10 years ago, the trend was to go towards pure yeast cultures and away from native yeast strains. I think that still continues for more, well, I think that's always been the case for kind of industrial winemaking or very large scale winemaking. But I would say for the the most expensive wines that you'll come across are generally native ferments. And I think a lot of other wineries maybe that don't fit in that super high prestige price bracket are like, like maybe I should be doing that too. Maybe that's how I can get the complexity of these wines. And I think, a slower fermentation, a less healthy fermentation in quotes, can sometimes produce more of those, more of that spice or those tertiary notes that that really, wonderful wines are known for, when you're using selected yeasts that are, much more efficient, you're you're kind of blasting through the fermentation process, creating alcohol, not necessarily all the other compounds that native yeast and bacteria, for that matter, are going to give you. So it's pretty interesting. That's not just I think the natural wine world, generally has a no yeast added sort of policy, but places that are using, sulfur dioxide and, that might not fit under that umbrella of natural wine are doing this as well.
Great. Thank you so much. Thank you to all of you for coming and talking with us today and sharing your knowledge with us. This has been so enlightening. Thank you to all of you in the audience for attending today's webinar. We will post a recording of this webinar on TFA's website in the next 24 hours. We also have a number of great webinars coming up in the next few weeks, including artisanal agave spirits, advances in yeast, and measuring and monitoring fermented food microbes. Please go to fermentationassociation.org to check these out and register. And while you're there, subscribe to our YouTube channel. Thank you so much, guys.
Thank you, everyone.